Hello, family, and welcome to my course, ChatGPT, Artificial Intelligence and the Rise of the Machines. My name is Chad, that's right, with two D's. I'm glad you decided to take action and join the family, so please help spread the word to others that you know may like something like this or need something like this in their position where they are in life or what they want to do next. They may be interested. Please help spread the word. So, who am I? Who is your instructor? Well, for starters, yes, this is me in the picture, and this was taken with a digital camera, but then artificial intelligence turned it into an AI-looking picture like this, which I thought was cool and appropriate since this course is all about AI, the foundation, the fundamentals of AI. And now that picture was taken in Ecuador with my llama friend Paco. I do love traveling. My wife is actually from Ecuador as well. Now, one of my passions has always been artificial intelligence or tech in general, but definitely artificial intelligence the last few years. I have a BS degree in Earth and Environmental Science, so I've always been a left-brain analytical type of person, and I've been a tech geek again since I was a little kid, so I love all things science. So think of this 101 course as the rock in which you will build your fundamental knowledge of artificial intelligence. Yes, this is a 101 course. It's very simple, it's very educational. But you just have to remember that the law of the world, the law of the universe, is that the foundation is the most important. You cannot build up or build out without continuing to have a strong foundation of what you are building. So yes, this is a 101 course, but you will build your fundamental knowledge of AI. Now, through this course, you will gain a better understanding, including its definitions, how it functions, and its potential impact on our world, your world, also, whether you are seeking to expand your knowledge and skill set, or you're simply just interested in exploring this exciting field. I can assure you that this course is the perfect starting point. Now here is what you can expect to learn from this course. Introduction to AI. We'll start by getting a general understanding of what AI is, how it works, and its potential to change our lives. Machine learning fundamentals. We'll cover the basics of machine learning, including supervised and unsupervised learning, and how computers can learn from data. Supervised learning algorithms. We'll take a closer look at supervised learning and explore popular algorithms such as linear regression and decision trees. Unsupervised learning algorithms. We'll dive into unsupervised learning and look at algorithms such as clustering and dimensionality reduction. Deep learning and neural networks. We'll dive into deep learning, including feed-forward networks, convolutional networks, and recurrent networks. Computer vision and image processing. We'll learn about computer vision and image processing, including image filtering, segmentation, and feature extraction. Natural language processing. We'll cover NLP and learn about text processing, sentiment analysis, and part of speech tagging. Robotics and reinforcement learning. We're going to learn about kinematics, dynamics, and control, and popular reinforcement learning algorithms such as Q-learning. We're going to explore the impact of AI on society and ethics and the importance of considering the ethical implications as AI continues to advance, and then we will move on to more information such as AI in healthcare, AI in finance, AI in retail and in manufacturing. I'll talk about ChatGPT and where it started, what it can and cannot do, and what the future holds. So listen, this course may be able to get you some credit for an additional course, maybe at a community college or somewhere else, possibly. All you have to do is just take your certificate of completion once you finish and ask them. So get ready to learn some new things, and most importantly, you all, have fun with this. In this lesson, we'll start by getting a general understanding of what AI is, how it works, and its potential to change our lives, as well as some general definitions to get you going. So artificial intelligence commonly referred to as AI, is the field of computer science that focuses on the development of algorithms or algos in computer programs that can perform tasks that would typically require human intelligence to complete. This includes tasks such as recognizing patterns, making decisions, and learning from data. And AI can be broken down into two main categories to keep it simple. One, narrow or weak AI, and two, general or strong AI. Narrow AI refers to AI systems that are designed to perform a specific task, such as playing a game of chess or recognizing speech, for example. And these systems are trained on a specific set of data and can only perform the task that they were designed for, nothing else. So contrary to narrow AI, general AI refers to AI systems that are capable of performing any intellectual task that a human can. However, this type of AI does not yet exist and is the focus of ongoing research and development. There are several key technologies that form the foundation of AI, including machine learning, very important, computer vision, and natural language processing. Machine learning is a subset of AI that involves building algos that can learn from data and make predictions or decisions. This can be done through supervised learning, where the algorithm is trained on a set of labeled data, or unsupervised learning, where the algo is trained on a set of unlabeled data. Computer vision is another key area of AI that involves using algos to interpret and understand images and videos. This can include tasks such as recognizing objects or detecting edges and segmenting images as well. Natural language processing, or NLP, as mentioned earlier, involves using algos to process and understand human language. And this can include tasks such as sentiment analysis, text classification, and part-of-speech tagging. AI has the potential to greatly impact our lives and the world as a whole. In many industries, AI is being used to automate tasks and make processes more efficient. For example, in healthcare, AI is being used to analyze medical images and assist with diagnoses. In finance, AI is being used to analyze stock prices and make investment decisions. And not surprisingly, AI is also being used in areas such as robotics and autonomous vehicles, like your Teslas, where it is helping to create more advanced and capable systems. One of the biggest potential impacts of AI is the potential to augment human intelligence and capabilities. AI has the potential to help us make decisions not only faster and more accurately, but it can assist us with tasks that are beyond our current capabilities. This is huge. However, as AI continues to advance, it is important to consider the ethical implications and the impact that AI may have on society as a whole. And so next, I'm going to give you 15 definitions of some of the most important terminologies used in AI. And this is going to give you a good, again, foundation to start learning the lingo of what these terminologies mean in AI. Number one, artificial intelligence, or AI. This is a study of how computers can be made to perform tasks that normally require human intelligence. Two, machine learning, or ML for short. This is a subfield of AI that focuses on teaching computers to learn patterns in data and make predictions. Number three, deep learning, or DL. Deep learning is a subfield of machine learning that uses neural networks with multiple layers to perform complex tasks such as image and speech recognition. Number 4, neural networks. This is a mathematical model used in deep learning that is inspired by the structure and function of the human brain. Number 5, supervised learning. This is a type of machine learning where the algos are trained on a labeled data set and they make predictions based on past examples. Number 6, unsupervised learning. This is a type of machine learning where the algorithms are trained on an unlabeled data set and must find patterns and relationships in the data on their own. 7, reinforcement learning. This is a type of machine learning where the algorithms learn through trial and error by receiving rewards or penalties for certain actions. Number 8, natural language processing, or NLP again. Now this is a subfield of AI that deals with analyzing, understanding, and generating human language. 9, computer vision. This is a subfield of artificial intelligence that deals with teaching computers to interpret and understand visual information from the world. 10, robotics, which is a branch of engineering that deals with the design, construction, and operation of robots. Number 11, autonomous systems. These are systems that can operate independently without any human intervention. Number 12, predictive analytics, which is the use of data, statistical algos, and machine learning techniques to identify the likelihood of future outcomes based on historical data. Number 13, chatbot. This is a computer program designed to simulate conversation with human users, especially over the internet. Number 14, expert system, which is a computer program that uses knowledge and reasoning to solve complex problems that typically require human expertise. And number 15, generative adversarial networks, or GANs. Now this is a type of neural network used for generative tasks such as generating images, music, and text by pitting two networks against each other in competition. So in conclusion, it is important to have a basic understanding of AI and its key technologies, which include machine learning, computer vision, and natural language processing. As AI continues to advance, it is important to consider the ethical implications and the impact that AI may have on society. And so this course will provide you with a foundation for understanding AI and its potential, and will equip you with the knowledge and skills you need to continue learning and exploring this exciting field. In this lesson, we'll cover the basics of machine learning, or ML for short, including supervised and unsupervised learning, and how computers can learn from data. Machine learning is a subfield of artificial intelligence that involves building algorithms that can learn from data and make predictions or decisions. The goal of machine learning is to create models that can generalize from data and make accurate predictions or decisions on new, unseen data. There are two main types of machine learning here: supervised learning and unsupervised learning. In supervised learning, the algorithm is trained on a labeled data set where each example in the data set has an associated label or target value. The goal of supervised learning is to learn a function that maps inputs to outputs based on the labeled data. Common applications of supervised learning include image classification, sentiment analysis, and regression. As an example of supervised learning, imagine you want to build a model that can predict the price of a house based on its size and location. You have a data set that includes information about the size location, and selling price of a number of houses. This data set is labeled, meaning that each example in the data set has an associated target value. So for this case, the selling price of the house. And so you use this labeled data set to train a machine learning algorithm. This is how this works. This algorithm uses the information about the size and location of the houses to learn the relationship between these inputs and the target value, i.e., the selling price. After the algorithm is trained, you can then use it to make predictions about the selling price of new houses based on their size and location. I'm sure everybody listening to this in the community knows about the websites of Zillow, Redfin, Trulia, and all the other ones that are doing this about home prices. They are using supervised learning algorithms to help them do this. In this example, the goal of supervised learning is to learn a function that maps inputs, or for instance, the size and location of a house, to the outputs, or the selling price of the house, based on the labeled data set, or the data set of the houses. Unsupervised learning, on the other hand, involves training the algorithm on an unlabeled data set. The goal of unsupervised learning is to find patterns or structures in the data without being guided by specific labels. Common applications of unsupervised learning include clustering, dimensionality reduction, and anomaly detection. As an example of unsupervised learning, imagine you want to cluster a large data set of customers based on their purchasing behavior. You have a data set that includes information about the customer's age, income, and the products that they have purchased recently and in the past. And so this data set is unlabeled, meaning that there is no target value or label associated with each example in the data set. You use this unlabeled data set to train a machine learning algorithm, specifically an unsupervised learning algorithm such as k-means clustering. The algorithm uses the information about the customer's age, income, and purchasing behavior to find patterns and relationships in that data. The algorithm then groups the customers into different clusters based on their similarities, with each cluster representing a unique segment of customers with similar characteristics. An algorithm is a set of instructions or steps for solving a particular problem or achieving a specific task, and it's expressed in a formal language that can be executed by a computer. Algorithms are used in computer programming and mathematics to perform various operations such as sorting data or searching for information and making predictions based on given inputs. In this example, the goal of unsupervised learning is to find patterns and relationships in the data without having a specific target value or label to predict. The unsupervised learning algorithm can be used to group customers into different segments based on their characteristics, which can be useful for targeted marketing campaigns or personalized product recommendations. Machine learning algorithms are based on the idea of using data to make predictions or decisions. This is done by training the algorithm on a data set where the algorithm uses the data to learn about the relationship between the inputs and the outputs. Let's take the example of a spam email classifier. The algorithm would be trained on a data set of emails where some of the emails are labeled as spam, while the others are labeled as not spam. The algorithm would then use this data to learn the patterns and relationships between the email content and the label. Once the algorithm has been trained, it can then be used to classify new unseen emails as either spam or not spam. There are several key concepts in machine learning that you need to understand in order to be successful. These include bias and variance, overfitting and underfitting, and the bias-variance trade-off. Bias refers to the difference between the predictions made by the model and the true values. Variance refers to the variability of the predictions made by the model. Overfitting occurs when the model is too complex and fits the training data too well, resulting in poor performance on new, unseen data. Underfitting occurs when the model is too simple and does not fit the training data well enough. So this bias-variance trade-off is the balance between having a model with low bias and high variance, or high bias and low variance. Another important concept in machine learning is regularization, which involves adding a term to the objective function that penalizes complex models. This helps to reduce overfitting and improve the performance of the model on new, unseen data. There are several common algorithms used in machine learning, including linear regression, k-nearest neighbors, decision trees, random forests, and neural networks. Each of these algorithms has its own strengths and weaknesses, and the choice of which algorithm to use depends on the specific problem you are trying to solve. And so in conclusion, machine learning is a subfield of artificial intelligence that involves building algorithms that can learn from data and make predictions or decisions based on that data. Hey, what's up, good people? In this lesson, we will dive even deeper into the topic of supervised learning and explore some of the most popular algorithms used for this type of machine learning. And just as a quick reminder, remember in the previous lesson we learned that supervised learning is a type of machine learning where the algorithm is trained on a labeled data set, with each example in the data set having an associated target value or label. And the goal of supervised learning is to learn a function that maps inputs to outputs based on that labeled data. And so linear regression is one example of supervised learning, and it is one of the simplest and most widely used supervised learning algorithms. It is used to model the relationship between a dependent variable and one or more independent variables. So what do I mean by this? The entire goal of linear regression is to find the line of best fit that models the relationship between the inputs and outputs in the data. And to illustrate this concept, we're going to stick with the house example. So let's consider the example of the house that we were using in the previous videos, and we want to predict the price of a house based on its size. So now we're sticking with the example of the house that I was speaking about in the previous videos, and now we're digging deeper into exactly how these algorithms work, how they think. And so in this case, the dependent variable is the price of the house, and the independent variable is the size of the house. So this is what we're talking about when it comes to linear regression and independent and dependent variables. The dependent variable when it comes to linear regression is the price of the house, and the independent variable would be the size of the house. And so we use a labeled data set that includes information about the size and price of a number of houses to train a linear regression algorithm. The linear regression algorithm finds the line of best fit that models the relationship between the size of the house and its price. And this line of best fit can then be used to make predictions about the price of new houses based on their size. Now let's talk about decision trees. This is another supervised learning algorithm that's very popular. Decision trees are used for classification and regression tasks, and they work by dividing the data into smaller and smaller subsets based on the values of the inputs. So think about this, the cliche of how do you eat an elephant? One bite at a time. So you break it down into bits and pieces. So these are how decision trees work. And the goal of decision trees is to find the split that results in the highest informational gain, which is a measure of the reduction in entropy or impurity in the data. To illustrate the concept of decision trees, let's take an example where we want to classify whether a fruit is an apple or an orange based on its size and color. In this case, the dependent variable is the type of fruit, apple or orange, and the independent variables are the size and color of the fruit. We use a labeled data set that includes information about the size and color of a number of fruits to train a decision tree algorithm. The decision tree algorithm starts by finding the split that results in the highest informational gain. For example, it might split the data based on the size of the fruit. If the size is small, the fruit is classified as an orange. If the size is large, the algorithm will then split the data again based on the color of the fruit. If the color is red, the fruit is classified as an apple. If the color is yellow, the fruit is classified as an orange. This is a very simple example, but it demonstrates how decision trees can be used to make predictions about the target variable based on values of the inputs or the input features. So in this lesson, we have covered two of the most popular supervised learning algorithms, linear regression and decision trees. Linear regression is used to model the relationship between a dependent variable and one or more independent variables, while decision trees are used for classification and regression tasks and work by dividing the data into smaller and smaller subsets based on the values of the input features. Both algorithms can be used to make predictions about the target variable based on the values of the input features. In the next lesson, we will explore unsupervised learning algorithms, including k-means clustering and hierarchical clustering.